In today's session, we'll try to understand about something called stateful set. So, what is stateful set? How it works, and how different it is from the deployment and other Kubernetes resources or objects. We'll try to understand. So, stateful set is also one Kubernetes resource and a controller. Stateful set also will create and manage the pods. So, basically, as you already know, deployments are usually used for stateless applications. Daemon sets are used for agent-based applications. This is stateful set for stateful applications. So deployments are usually used for stateless application. However, we can maintain the state of the pods created and managed by deployment also using values. By attaching a values, we can maintain the state of the pods created and managed by deployment also. But actually, the recommended for these deployments are recommended only for stateless application. Right? So here, if you see, deployments are usually used for stateless application. However, you can save the state of the deployment by attaching a persistent values. As I already said, you can attach the persistent values to the pods of the deployment and you can make that stateful. But all the pods of the deployment will be sharing the same value. And the data across all of them will be same. What does it mean? Suppose you are creating a deployment with the multiple replicas. Let's imagine this is your Kubernetes cluster. In this cluster, you have some nodes that can be master node or a worker node. You have some nodes where the pods will be scheduled. You have a controller node or a master node, right? Worker nodes like that. Let's imagine you have a nodes, master node or a nodes, multi-master for high availability. Here you have a pods. Let's imagine you are trying to create a pod. That pods are managed via deployment. Let's say you created a deployment. So deployment internally created a replica set. That replica set will internally create and manage the pods. Let's say you created a deployment. This deployment internally create a replica set. Whether you are directly creating a replica set also same. Whether you are directly creating a replica set also same. Let's imagine you are creating multiple replicas, multiple pods. Multiple pods for this deployment. Let's assume you created a deployment like this or a replica set, whatever. Whether you are directly creating a replica set, whether you are creating a deployment internally replica set, that doesn't matter. Suppose you are creating 2 replicas or 3 replicas, and here you are attaching values, persistent value. You are having values. Let's say you are attaching some kind of a value. Let's imagine you wanted to have a multiple pods. Let's say you have created a persistent value claim and you have attached a value. Here you have a image. Let's imagine you have done this way. You have total, let's say 2 pods, 3 pods. You created a PVC and you are attaching a PVC for that. So here you have a PVC. Even though this PVC you are requesting read write many also, okay, that doesn't matter here. Imagine you have a PVC, and this PVC will be bounded with some PV. That persistent volume can be any type of volume. Whether the, let's imagine these are using this PVC as a volume. This PVC is associated with some PV, persistent volume. That persistent volume can be internally host path, NFS, that doesn't matter. So here what I wanted to say here is, so if you use deployment, right, all the pods of the deployment will be using the same value. So deployments are usually used for stateless application. However, you can save the state of the deployment by attaching a persistent volume to the pods, and you can make it stateful, but all the parts of the deployment will be sharing the same value, and the data across all of them also will be same. But in some scenarios or some requirements, each replica, each pod, let's say each pod should have its own value, not shared value. Suppose this pod also using same value, this pod also using same value, this pod also using same value. When we are going to use deployments or a replica sets, all the parts of the deployments or a replica set or even replication controller also do the same. But in some certain scenarios or some certain use cases, each replica should have its own value. In that case, the deployment will not support that. Suppose this part should have its own PVPVC. This part should have its own PVPVC. And this part should have its own persistent value and value claim, not a shared, right? So if you have these type of requirements, then the deployment will not support. You have to go with the stateful set. So you may have some applications, or softwares. You need to replicate your application into multiple replicas, and each replica should have its own network identity and network storage. I mean, so each replica should have its own storage and its own network identity also. In certain scenarios, this deployment or a replica set will not support this type of thing. Suppose you are creating a 3 replicas, 3 pods or a 2 pods. Each pod should have its own stable storage, right? Each pod should have its own storage. But all these pods are belongs to same same application that can be created via some Kubernetes resource. But if you are using a deployment to create a multiple replicas, and if your expectation is each replica should have its own volume like this, then deployment will not support. Even replica set also will not support. Replication controller also will not support. So this is where the stateful set comes into the picture. Suppose if you are using a stateful set will provide a stable storage for each replica that the stateful set is going to manage, and again stable network identity. Network identity means host names, stable host names. Suppose let me take one use case, or let me take one scenario, then I will try to explain this stateful set also. As of now, let's say you are deploying a database. As of now, you are running a database to store some kind of a data by application, right? So application is storing the data, retrieving the data, and updating the data in the database. Let's say if you take any applications, definitely will have some or the other databases are being used. That can be relational databases or a SQL databases, we call it, like MySQL, Oracle, PostgreSQL, MariaDB, IBM DB2, or maybe document oriented or NoSQL databases such as MongoDB or any other. If you take any applications, definitely that applications will use some kind of a database to store and retrieve and update or manipulate the data. Suppose whether you are using a virtualized deployment, whether you are using a containerized deployment, suppose if you have only one replica of the database, only one instance of the database, only one replica of the database, right? Whether it is deployed in a virtual machine directly, or maybe whether you are deploying in Docker as a container, or maybe in Kubernetes as a pod. So let's imagine, suppose if you have only one replica, one database, in real time, do you think it will be able to support so much load come to the database? Do you have availability tolerance in the database if you have a single replica? Whether it's a virtual machine or a virtualized deployment or a containerized deployment, that doesn't matter here. Single replica, only one instance. Whether it is a virtual machine also, same. Let's say you have a VM. This VM can be non-prem or a cloud like AWS, Azure, GCP, that doesn't matter here. Let's say you have a VM, in this you have a OS, and this server will definitely use some storage. Servers also use storages. There is something called root storage to boot the OS. If required, within this root storage itself, it will maintain the data, root storage, root volume. Otherwise, suppose you can attach additional volumes also that we have discussed in AWS cloud, right? Maybe you can attach one more volume also to this VM, and you can mount that separate folder. OS will be booted here, data will be stored here, like that. You can do that in case of virtualized deployment, virtual machines. Imagine this is where you have installed your database like Mongo. Applications, whether applications are running again as a containers or as a pods or maybe virtualized deployment, applications are talking to the DB. Let's say this is your application instance. This application might be you have replicated for high availability. Whether it's a virtual machines or a containers, or that doesn't matter. This application instances or applications are talking to this DB. This application is hosted again maybe in a virtual machines or a containers or maybe in Kubernetes pods, that doesn't matter. For high availability in the application, you have a multiple replicas. You are bringing a reverse proxy or a load balancer in front of this to distribute the load. But internally in the backend, this application talks to the DB. Suppose you have a single replica of the DB like that, whether it's a virtualized or containerized or Kubernetes pods. Let's imagine something goes wrong with this server VM, if it is a virtualized deployment, or maybe even it is a containerized deployment also. Let's imagine if something goes wrong with this container. Again, if you are using Kubernetes also fine. Suppose if something goes wrong with that pod where the database container is there, maybe it will try to recreate. But before the Kubernetes try to reschedule or recreate the database replica, your application is, I mean to say, your database is down, your applications are not able to read and write the data. And also, let's say sometimes something goes wrong with this storage. Suppose sometimes something goes wrong with this storage. Then you have a database process running, but this process is not able to read and write the data to this storage. Again, you have a problem, right? So, and again, there is so much traffic. There is so much traffic or so much request. So much traffic or so much request comes to this database. If you have a single replica or a single instance of the database, again, database becomes so slow. Performance bottlenecks, performance issues, performance down. Right? Even though your database process is up and running, even though the storage that is used by your database is also fine, sometimes this database performance will go down or performance will be slow, but like slow application will become slow because the database is responding slowly. So in real time, definitely we need to replicate the databases also. Definitely you need to replicate the database, whether it's a virtualized deployment or a containerized deployment, that doesn't matter. So you have to replicate, duplicate the database. But understand, the database replication is a little different from application replication. Suppose if you just created three different servers, suppose if you just created three different servers and if you just install databases, softwares in 3 servers, that doesn't replicate the data. Here data also has to be replicated, right? The data also has to be replicated. If you just have 3 replicas of the database, whether it's a container replicas or a virtual machine replicas, that doesn't matter. If you just create a 3 database instances and if you just install the database, which doesn't mean, right, we are replicating. So these applications are a database clients, we call it. These applications are a database clients, we call it. These applications has to talk to these databases, right? So here you are not going to, I mean, say this application has to talk to all these databases, right? Here let's imagine it is not like one application instance will talk to one db, another application will talk to another db. It is not like that. Suppose suppose this application is talking to this database server and this is storing the data here. Maybe another application or a same application instance, next time if it is talking to this database server or a database instance, the data, if the data is not replicated here, the data is not replicated to this database process, you don't see a data consistency again, right? Data consistency, data integrity. So here you need to replicate the databases, means you need to, it is not like just creating 3 replicas. You have to configure a replication in the database processes also. There is something called primary db, there is something called secondary DB. So you have to initiate the database replication. So database replication is like a no, it is like a one process of replicating the data between multiple database instances also. So here there is a concept called database primary, database secondaries, primary database replica, secondary database replica, and each database replica should have its own copy of the data also. It is not like a shared storage. Each database replica should have its own storage. Data also we are replicating. So data also we are replicating. We should have a multiple copies of the data. Database process, you should have a multiple processes of the database, and again we should have a multiple copies of the data. Each database process or a replica should have its own copy of the data. So even though one of the database replica is having issue, if the data is replicated and we have a multiple replicas of the data, is the application can still continue to read and write the data from other database replicas from that replica of the data? Yes. So here there is something called database replication, primary DB, secondary DB, like that. So each database replica should have its own storages like this. And here, let's imagine you have to replicate, so primary DB, secondary DB concept is there. All the write operations will be carried via primary DB. All the read operations will carried via secondary DB, right? Write operations means creating data, updating data, deleting data will happen via primary DB, and the read means a select, reading the data will happen via secondary DB. But primary DB should know where the secondaries are running, because any data that is being written to the primary DB, the data has to be copied synchronously or asynchronously. Synchronously or asynchronously, the data has to be copied to the secondaries, so that if any database client goes to the secondary, there should be a data, right? So it is a primary DB responsibility. It is a primary database responsibility to replicate the data to the secondary database replicas. And again, our applications or database clients will use all these primaries and secondaries also as a database connection, database host. So it will use all these database, primary database, secondary database details also to the talking. Suppose let's say this is your primary database server IP. Let's say you have a virtualized deployment. Let's say this is your IP address of the database, one of the database. Let's say again this is another database IP. Suppose if you are using cloud like AWS or Azure or GCP, better to replicate these databases into multiple availability zones in that region. Multiple availability zones. Like instead of creating all these database servers in single availability zone, you can have this server in one zone, this server in another zone, this server in another zone. Like this storages also are in their zones according to that zones it will be there. Now let's imagine if you just create a 3 database servers and if you just give applications these database servers IPs and ports, like you will give like this, but these applications will try to talk to, it will try to identify, it will try to identify which one is primary, which one is secondary, like that. The database drivers which is part of your applications, the database drivers which is part of your application, it will try to identify out of these replicas, out of these many database instances or a database replica, which one is primary, which one is secondary, like that, it has to identify. But first, you have to configure that database replication, because imagine out of these, someone has to be primary, but primary knows where the secondaries are running, because when any data created in the primary, the data has to be replicated or copied to the secondary without knowing its details, without knowing its details where the secondary replicas are running. The primary will not able to talk to that secondaries, or primary will not able to replicate the data to the secondary. So in one of the database process, you have to execute some database commands or a database configurations you have to set up. So let's imagine this is database administrator job. Let's imagine in this database process, you are trying to set up the replication. So here you will try to give all the database instance details, replica details. Let's say maybe IP address or a port number. You will give, like you are going to initiate the replication. You are going to add the members. You are going to add the members to the primary. Like you are going to add all these details in the one of the database, let's say. Now you will initiate the replication by executing some commands or by updating some configuration files in the database. Right? Let's imagine you made this as a primary DB or a master replica or a primary DB, and primary should know where the secondaries are running. You are giving these details so that these applications is going to use all these databases. The database drivers are in this database clients or applications will identify out of these. You will give all these details. There is no load balancing here. There is no load balancing here. It is not like one time it will talk to one DB, another time it will talk to another DB. It is not like that. So you will give all these endpoints, database endpoints. So out of these, the database drivers will identify which one is primary, which one is secondary. So based on the operation it is trying to do, if it is a create operation or update or delete, it will contact primary. If it is a read, it will contact secondary, like that. So here this will go and talk to primaries also and secondaries also. Primary for write, secondary for read, like that. So whenever any write operation happened in the primary DB, right, the primary will replicate the data to the secondary DB. So primary, let's imagine this is primary. Any application created some data, so the database process here will process that data request and it will try to store the data here. And again, this primary will try to replicate the data to the secondaries also, synchronously or asynchronous. This is database concept: synchronous replication, asynchronous replication. Synchronous means after creating the data in the primary, immediately it will try to replicate the data, then only the database operations will be successful, like that. Asynchronous means it will just write the data in primary, then it will confirm the applications I have written the data, like that. Then after that, asynchronously it will replicate. That is asynchronous replication. Synchronous replication, like that, we have a database replications. And here let's imagine we have a multiple replicas of the databases, and each database will have its own storage where it is storing the data. This is the process, this is the storage. This is the process, this is the storage, like that. Now what is the advantage with this database replication? Right? High availability, and again high availability, durability. We have a data replicated in multiple replicas. Again, even though one of the copy of the data also have some problems, still we have a data in the other copies, right? Availability, durability, and fault tolerance, right? So here performance also will be improved. Now your applications will not depend on single replica, right? So read operations will be read operations will go to some other servers, other replicas, write operation will go to primary server. So performance of the database also will be improved. Performance of the database also will be improved. At the same time, we have a high availability, durability. Suppose let's imagine something went wrong with this primary itself. Something went wrong with this primary itself. Primary knows where the secondaries are running and secondary knows which one is primary, right? Suppose something goes wrong with this primary, all of a sudden, out of these secondaries, one will become a primary again. Out of these secondaries, one will become a primary because there will be kind of a health checks also between primaries and secondaries, right? Health checks means whether they are healthy or not, like that. Suppose the secondaries are not able to reach the primary. Okay, the secondaries will think primary is down. So in this case, one of the secondary becomes primary. Then your applications will still talk to the database and write the data, and we will still applications will still able to talk to the database and read the data also. So we have a availability, fault tolerance, and basically and durability also here. So performance also improved. But here each database should have its own storage, and each database should have a stable network identity. This type of host names or IP addresses should be same, fixed. So in this scenario, some use cases or scenarios, you need a stable network identity. I mean, it's a stable network identity means a stable host names or IP addresses and stable storage. You can set up like this in on-premise environment in virtual machines, or you can set up this in cloud environment like AWS or Azure or GCP directly using infrastructure services like EC2 or Azure VM or Google Compute Engine. Otherwise, if you are using cloud like AWS, if you don't want to worry about creating a required database servers, and you don't want to worry about this database storages, and you don't want to worry about configuring these type of replication, then we have a managed databases also, database as a services. Suppose if you are going with the database as a services like relational database, RDS, document oriented database like DynamoDB in AWS, right? So you no need to create the required servers, and you no need to worry about the storage, you no need to worry about the scalability of the servers and storage, you no need to worry about replication. Who is going to set up all these things in the background, creating a servers, installing a database, and configuring a replication? Cloud service providers. So most of the administration task, will be taken care by the cloud service providers. Database administration task, right? But let's say if you wanted to do yourself in on-prem also, you can do that, or in cloud also you can do that. But this is how the databases also will be replicated and it will be used. But now let's say I wanted to bring this to the Kubernetes world. I wanted to set up these type of database replication. I wanted to set up this type of database replication within the Kubernetes clusters. That Kubernetes cluster can be in on-prem or a cloud, that doesn't matter again. So I wanted to run these databases also as a containers in my Kubernetes pods, and I wanted to bring this type of replication. Now let's say if you wanted to bring this to Kubernetes, suppose I will create a database like this. I will create a maybe deployment or a replica set, that doesn't matter, or maybe replication controller or a replica set, or maybe the deployment with the 3 replicas. And if it is a containers in Kubernetes, if your containers are deleted and recreated, you lost the state, you lost the data, right? That is why we are using volumes. Okay, you are using persistent volume. But let's imagine you are creating 3 replicas. 3 database replicas like this. But if I use deployment, do you think we will get this type of thing? Each database replica means each pod. Do you think it will get its own storage like this if I'm using a deployment? No. Deployment or a replica set or if you are using deployment or a replica set, or maybe if you are using replication controller, all of the pods will be sharing the same persistent value. That is what one thing. And not only that problem, let's say stable store network identities also we need. Stable network identities. Suppose I have to set up a replication. So here each pod will have its own IP address. Each pod will have its own IP address and host name. But these type of things I have to set up maybe by executing some database commands, by executing some kind of a database commands, or by by updating some configuration file here. I need to, because this primary should know where the secondary is running. This should know where it is running. Suppose here we need a stable network identity also. Suppose if I am using pod IPs, each pod will have its own IP here. Suppose if I try to set up this type of replication within the database process running in a container using that pod IPs, do you think pod IPs are stable if you are using deployment or any other things also? No, pod IPs will be dynamic, different. And again, suppose something went wrong with this pod, even though again pod is created, but with whatever IP I have configured the replication, maybe same IP it should come. But this pod will come with a different IP. If it is coming with a different IP, is this database process using that IPs or host names, will it able to again communicate with this new pod, even though pod is created again? If the IP is changed like that, or host name or IP is changed, no. So again, there is a problem. Pod IPs are dynamic. Suppose pod names are like a host names. Pod names are like a host names. Suppose if you are using deployment or a replica set or a stateful set, again, do you think the pod names will be again stable? The host names or a pod names will be stable? No. Right? Again, pod names also dynamic. But in some scenarios or applications or use cases, you may need a stable network identity and stable storage also. In that case, you can go and use a stateful set. Suppose you need some kind of a stable network identity. Stable network identity means even though pods are deleted and recreated, the host name, the pod name or a host name should be remain same. And stable storage. Each pod should have its own storage. Again, wherever this pod is rescheduled, recreated, that pod should use same storage, and that pod should have a same network identity. Like that, if you have such type of requirements or such type of scenarios, you can go and use stateful set. So database replication is different, Kubernetes stateful set is different. But what I am trying to say here is, so stateful set, if I am using, stateful set provide a stable network identity and stable storage also. Suppose any process or application is looking these type of features, then you can go and use a stateful set. So before I start explaining about stateful set, I hope you are getting the whole point of the stateful set also here, along with one use case. So stateful set is also one Kubernetes resource. But database replication is different, stateful set is different. It is both are not same. But in Kubernetes, you can use the stateful sets to deploy and manage the stateful application like databases also. And the stateful set provides a stable network identity, stable storage, and again, right, ordered deployments like that. So stateful set is also one Kubernetes resource. Stateful set is one Kubernetes resource. Use it to manage stateful application. That stateful application can be database, or that can be any other stateful application like Jenkins, or maybe any other also. You can use a stateful set. So stateful set is also one Kubernetes resource. It will manage the stateful application, and it will create a pods and it will manage the pods. Using stateful set also, you can increase and decrease the pods. But this stateful set provides a guarantee about the order in which the pods will be created and uniqueness of the pods. The stateful set, while creating itself, it will create one after the other. First replica will be created. Once the first pod is created, then only second pod will be created, then only third pod will be created. Order. It is going to create from 0 to n. When you are deleting the stateful set, the pods will be deleted in a reverse order also. And again, each stateful set pod will have its own uniqueness, right? So stateful set is also one Kubernetes controller or Kubernetes resource. It is going to create and manage the pods, but it is not like a deployment. So if I am using a deployment, right, deployment will internally create a replica set, then it will create a pod. But if I am using a stateful set itself directly create a pods and manage the pods. And again, stateful set pods, it will create with some naming conventions also. Suppose if I am creating a stateful set with a name called Mongo, just to give an example. Suppose my stateful set name is, suppose I am creating a stateful set. Instead of deployment or a replica set, let's say I am creating a stateful set. Suppose here if I give 3 replicas, my stateful set name is just MongoD, like Mongo database, like that. The pod names, right, will be like MongoD-0, MongoD-1, MongoD-2, like that. You will have a pod names. These are like a host names of your pods. Again, whether they are deleted and created also, with same names it will come. That's what we are trying to say here. So stateful set will create a pods with unique naming conventions. Suppose example, if you create a stateful set with a name called Mongo, then it will create a pod with the name like Mongo-0, Mongo-1, Mongo-2, like that. The names will be incremented like this. And again, every replica of a stateful set, every replica means every pod. Every replica means every pod of the stateful set will have its own state. Every replica means every pod of it's a stateful set. Suppose here I am creating a stateful set with the 3 replicas, let's say. Here I am creating a stateful set with 3 replicas. It is like this. Every replica means every pod will have its own state. Own state means it will have its own persistent volume claim, like that, own storage. So every replica of a stateful set will have its own state, and each of the pods will be creating its own PVC. Each of the pods will be creating its own PVC, and respective PV will be there. So suppose if I create a stateful set with the 3 replicas, it will have a 3 pods and each having its own value. So total 3 PVCs and 3 PVs. For each PVC, there will be 1 PV. Suppose if I create a stateful set with 5 replicas, then 5 pods, then how many persistent volume claims and how many persistent volumes? Suppose if I create a stateful set with 5 replicas. So 5 persistent volume claims and 5 persistent volumes. And again, if required, you can scale in, scale out also. You can increase and decrease the replicas of a stateful set again. Based on requirement, you can increase and decrease also. That is how you can do that, right? So here, the stateful set feature is fully supported in Kubernetes 1.9 version. So the most of the common ways to deploy and manage the databases in Kubernetes is actually stateful sets. Not only database, any other stateful application, you can use stateful set. So stateful set has some features, some requirement. I mean, some features. So stateful set provide unique, stable and unique network identity. Stateful set provides a stable, unique network identity. Stateful sets provide stable, so stateful set provides a stable and unique network identity. What does it mean? Like each pod in a stateful set is going to have a host name. Each pod in the stateful set is going to have a host name that is based on the stateful set name and increment. For example, suppose if I am creating a stateful set with a name called Mongo, each pod will have its own, host name. That is like Mongo-0, Mongo-1, Mongo-2, like that. So unique network identity. Even though your pods are deleted and recreated for some reason, the stateful set pods will have again created with same network identity also. And again, stable persistent storage. As I already said, each and every pod in the stateful set each and every part of a stateful set in the cluster is going to have its own persistent value based on the storage classes that we have created. Otherwise, if you have pre-created the values, right, the persistent value claims of that stateful set is going to get the value. Otherwise, the storage classes will create the value for that claims. Then each part each part of the stateful set in the cluster will have its own value and value claim. Suppose if you are deleting and scaling down the parts, will not delete the values associated with that stateful set parts. Suppose you are scaling down, scaling up the parts, or scaling down the parts of a stateful set, or deleting stateful set also will not delete the values associated with them, because the data will still persist and you can again use that. And again, it provides ordered and graceful deployments. So parts of the stateful sets are created in order from 0 to n, from 1 to n, let's say. And suppose when you are creating a stateful set with the 3 replicas, first replica will be created. Once this is ready, then only second replica will be created. Then only third replica will be created. Suppose when you are deleting in a reverse order, first nth replica or a last pod will be deleted, then again n-1 pod will be deleted, then like this it will delete in a reverse order, creating from 1 to n, deleting from n to 1, like that. Right? So stateful set parts are created and bought online in order from 1 to n, and they are shut down in a reverse order to ensure a reliable and repeatable deployment and runtime. The stateful set will not even scale until all required parts are running. Right? So if one of the pod dies, it will recreate the pod. It will recreate the pod before attempting to add additional pods also. Right? So this is how the stateful set will work. And again, stateful set we can update also. We can update the stateful set. Suppose you are updating the part template of a stateful set. Again, if you update, old parts will be replaced with new parts also, like that. Again, the new parts also will be reusing same persistent value claims, and again, it will have a same network identity also. So if you see here, there is a detailed documentation about stateful set in Kubernetes, official documentation. Here they are saying key features of a stateful set: stable network identifier, stable persistent storage, ordered and ordered deployment, like that. There is something called headless service. I will tell you about that headless service also. These stateful sets are ideal for applications requiring a persistent storage and stable identities, like such as databases like MySQL, PostgreSQL, and message queues like Kafka, RabbitMQ, Kafka, and any other distributed systems that rely on individual pod state. Right? So here, if you see, stateful set will run group of pods. Stateful set will create and manage the group of pods, and it will maintain the identity, sticky identity for each of these pods. Sticky identity means each and every replica of a stateful set will have a same network identity and same storage, even though they are rescheduled, recreated on a different nodes also. This is useful for managing applications that need persistent storage or a stable, unique network identities also. Right? So stateful set is also one Kubernetes object used to manage stateful applications. Right? This stateful set will deploy and scale set of pods and provide guarantee about the order and uniqueness. Uniqueness means network identity and storage. Each pod will have its own network identity and storage. Stateful set, it is going to create and manage the pods again directly. Right? So using a stateful set. Stateful set is valuable. Stateful sets are valuable for applications. Stateful set are valuable for applications that require one or more of the following. Suppose if any of the application or a process require one or more of the following, like a stable unique network identity you need, or maybe stable persistent storage you need, one or more features. If stateful sets are valuable for the applications that require one or more features of the following, like if any application requires stable and unique network identity, or a stable and persistent storage, ordered or a graceful deployments, right? Updates, then you can go and use the stateful sets. Suppose stateful set have some kind of a limitations also. Stateful set have some kind of a limitations also. Suppose, just to give an example, now this is what I wanted to do in my Kubernetes. This type of setup I wanted to do in a database. I know Kubernetes. I wanted to have a multiple replicas of the database. Each replica should have its own storage and again stable network identity, right? At least two I need: stable storage and stable network identity, right? Then can I go and use this stateful set for deploying these type of pod containers? Yes. And again, stateful set have some kind of a limitations. Stateful set have some kind of a limitations also, right? The storage given for the pod, because here each stateful set is going to create a PVC. That PVC requires a PV. You need a storage, right? This is pod, this is PVC. That PVC requires a PV, persistent value. We discussed in the previous sessions what is persistent volume claim, what is persistent volume, static volumes, dynamic volumes, storage classes. We discussed already. So the storage for the given pod must be either provisioned by persistent volume provisioner, that storage class dynamically, otherwise pre-provisioned. Let's imagine, suppose you don't have a Kubernetes cluster with storage class configured, and again if there is no persistent volumes pre-created, then is this stateful set pods will get the persistent volume via that PVC? Suppose if you don't have a storage class configured with the dynamic volume, and again if you don't have a persistent volumes pre-created, do you think the parts of the stateful set gets volume? No. But either you pre-provision the volumes as a Kubernetes admin, either you pre-provision the values, persistent values, and make them available for claims. Otherwise, you should have a storage class configured with some kind of a provisioner for dynamic value. But in our cluster, whatever cluster as of now I have configured a storage class with NFS provisioner. So even though I don't have a persistent values, the persistent values will be dynamically created based on that storage class using that provisioner for these pods. So limitation means make sure you have a values, otherwise storage class configured. That is what the limitation here. And again, deleting or scaling down the stateful set. Deleting or scaling down the stateful set will not automatically delete the values associated with it. This is not basically kind of a limitation. This is to done ensure the data is still available. So deleting or scaling down the stateful set will not delete the values associated with stateful set. Deleting or scaling down the stateful set will not delete the values associated with stateful set. This is done to ensure the data safety, which is generally more valuable than a limitation, because if you are deleting or scaling down the stateful sets, if the values also deleted, you lost the data. Again, if you scale up or create again, you don't see data. So this is not a limitation. Actually, this is done to ensure the data safety. This is more valuable than a limitation. And also, stateful set currently requires something called headless service. Stateful set currently requires a headless service that is responsible for the network identity. So you have to create a headless service, and you have to give that headless service details to the stateful set. The stateful set will use that headless service to give the network identity to the pods. So currently there is something called headless service. Stateful set currently require headless service. Stateful set currently requires a headless service. That stateful set currently requires a headless service that is responsible for assigning the network identity, assigning the host names to the pods, right? And again, you are responsible for creating a headless service. So what is this headless service? Sometimes in the interviews also they will ask, what is headless service? What is service and how many different types of services you have, and what is headless service, like that also. So we guys already know service. Service is responsible for making the pods. Service is used for communication, network communication. We are going to create a service. Service will identify the pods. So via services, we can communicate with the pods internally or externally. We can communicate with that pods. we have a different types of services. So far we learned. We have a cluster IP service, we have a node port service. Similarly, we have a load balancer service, that is external load balancer. Similarly, we have a headless service. Suppose if I am creating a cluster IP service, right? If I am creating a cluster IP service will identify its pods, its endpoints based on the labels and selector, and your cluster IP service will have a one IP, service IP or a cluster IP. This is like a cluster IP service. If that service has a multiple endpoints, it will identify the pods using labels and selectors. This will be added as an endpoints to this service. Within the cluster, if anyone is trying to communicate with this service using service name or a service IP also, then this service will try to distribute the load to the pods that belongs to that service like that. There is a distribution, load distribution, right? But this cluster IP services are reachable only within the cluster. Suppose if you wanted to access from outside, you are going to create a node port service. Via node port service, you can reach the cluster IP. Via node port service, you can reach that service, right? The node port services are reachable from outside the cluster also using node IP and node port. From outside, we can reach reach that node port service using node IP node port. Then it will go to service IP service port. Then again, it will distribute the load to the pods of that service. But for external communication, there is an external load balancer also. End users will not directly use node IP node ports. You are going to bring a load balancer. That I will explain in further sessions. But in a self-managed Kubernetes clusters, there is no direct integration with that external load balancer or load balancer service. We'll discuss that in further session. Similarly, there is something called headless service. What is this headless service? So this is also one type of service, right? When we are creating a headless service, it will not, for a headless service, you don't get a cluster IP. And again, this headless service does not do the load balancing also. This headless service does the load balancing, right? But headless service is also one type of service. Let me explain what is this headless service. We have something called headless service. Sometimes you don't need a load balancing between the pods and you don't need a service IP. Suppose you are creating a service, right? And you have a pods. This service will identify the pods. This service will identify the pods like a endpoints, right? These are like a endpoints of that service. Endpoints. And this is one endpoint. I mean to say one pod. This is one endpoint, one pod. This is another endpoint like that. Sometimes you don't need a load balancing and you don't need a service IP. In this case, you can create a headless service. So by explicitly saying in the service specification, instead of saying a type cluster IP, if I say cluster IP none, while creating a service, if I say something like this. Suppose while creating a service, you might have mentioned a type cluster IP, sometimes type node port like that. But instead of saying type cluster IP, type node port like that, if I say cluster IP none, this is like a headless service. So when I am creating a headless service like this service will identify the pods, to which pods it has to communicate. But it will not give any service IP. That headless services will not have a service IP or a cluster IP, right? And it does the load balancing also. Instead headless service give all the pod details. Whoever is trying to use that service name, instead they will give all the pod details. The clients or applications only can decide which IP or which pod it has to talk like that. So sometimes you don't need a load balancing and a single service IP. In this, you can create a headless service by explicitly saying a service specification cluster IP none like that. You can use this headless service. You can use this headless service to interface with other service discovery mechanisms without being tied to the Kubernetes implementation. So headless service. For headless services, cluster IP is not allocated. And kubeproxy does not handle these services or load balancing. So there is no load balancing or proxying done by the kubelet, that kubeproxy. So, but headless services will allow clients to connect with whichever pod it prefers. There won't be any load balancing, but it will give all the pod endpoints or pod IPs. The whoever is trying to communicate with headless service, they can only decide that application or a client only can prefer connect to whatever pod it wanted to connect like this. This services, this headless services, right? Services that are headless don't configure routes and packet forwarding like that, right? Headless service does the load balancing also. Sometimes you need this type of headless services. So for stateful set, you need to create a headless service and you have to you have to give that headless service details to the stateful set itself, because the stateful set use this headless service to assign the network identities also. So are you guys clear what is headless service also? Sometimes in the interview also they'll ask. Now they are giving some example. They are giving some example here, stateful set example, but they are giving using Nginx image. So if you see, they are creating a service explicitly they are saying cluster IP none. So this is like a headless service, and this service details has to be given when we are creating a stateful set. If you see in the stateful set specification, there is something called service name. So you have to create a headless service like this, and you have to give that headless service name to this stateful set. So the stateful set will use this headless service name to assign the network identity of the stateful set pods like that. And again, three replicas they are creating, and again using this template only the pods will be created by stateful set. The pods will be created. But here again, it is little different here. We are not creating a PVC, because PVC also will be created. PVC also will be created. PVC also will be created by the stateful set itself, because suppose if I am creating three replicas, it has to create a three PVCs. Suppose if I am creating one replica, it has to create a one PVC. So instead of you directly creating a persistent volume claim, you are defining something called volume claim template. The way we have a pod template, for creating a pods, the stateful set uses something called volume claim template. So the stateful set itself will create a PVC using this information. Like with this much storage, I need a persistent volume claim has to be created with this much storage with this access mode. This storage class has to create a PVC like that. Also, you can tell, because suppose sometimes if you are creating four replicas, it has to create a four PVCs. Suppose if you have to have a five pods, five PVCs. So you are not directly creating a PVC. The stateful set itself will create a PVCs using this volume claim template. Using this volume claim templates, PVCs will be created, and again using this pod template, the pods will be created. Each pod will get its own PVC again, and each PVC will get a PV. That PV can be dynamically created for that persistent volume claim based on the storage class, or maybe if you already have some values based on the access modes and reclaim policies, it will try to, based on the access modes and the storage, it will bound. So here the stateful set specification is little different from others. You have something called volume claim template. But here, whatever example they are giving, Nginx is not a stateful application. Nginx is like a web server or a reverse proxy. But let me take Mongo database and I will try to explain stateful set. But understand here, today I am explaining two different concepts: stateful set as well as database replication, like a DBA related thing also I'm trying to explain. Mongo database, how to set up the Mongo database replication, like primary, secondary, how to do all this. That is database replication, at the same time stateful set. Because I am using stateful set, because in order to set up the replication, I need a stable storage, stable identities. That's why. Not only for Mongo database, for any stateful application, you can use stateful sets. So clear? Before I deploy a Mongo database using stateful set, and before I set up a primary, secondary like that, everyone clear the stateful set concepts? Now, before you set up Mongo database replication, because you should know some commands about MongoDB. Because when you are trying to set up a Mongo database replication, you should know some commands, which commands can be used for setting up primary, secondary, like that. So that you can see this official website, MongoDB. This is like a official website of Mongo database. Community edition is there, documentation also there. This is the database. This database, Mongo database. Like Mongo database, if you are using MySQL also, you have a documentation. But how to set up a replication in MySQL is little different from Mongo. Concept is same, but the commands that you are going to use for setting up the replication, the files in which you are going to make some changes to set up the replication will be different. MySQL replication might be different, Mongo database replication might be different. But this is where they're going to explain what is MySQL, what is replication, why do we need replication, how to set up replication, also if required. Similarly, every database software also has a documentation. Otherwise, you can use some kind of a nowadays you have a chat GPT, you have a Google access to the Google access to the chat GPT. You can ask how to set up what is Mongo database replication, what is MySQL replication, how to set up the replication, why we need to set up the replication. In case if I have to do in Kubernetes, how to do that. So you can take a help also. But concept is important. Without concepts, you can't go for an implementation. For implementation, there are so many documentation, so many, help is there. But first of all, if you don't know the foundations or fundamentals or basics, then you will struggle, right? So that is what we are trying to cover here. Concepts are very, very important, guys. Now, if you see this Mongo database, there is a documentation also. Community edition we can use, and there is a documentation also. Resources, you can see documentation. So here you have a Mongo database community. So what is this Mongo database? How to install database? Also they're explaining what is the current version. You can install in anywhere. Suppose you can see you can install in Linux, Mac, Windows. Again in Linux, whatever directly servers, right? You can install as a tar. Suppose you wanted to install via Docker, there is an image also that we have already done. But if it is a Kubernetes, same image, but in Kubernetes, you are going to use these images and deploy as a containers using pods like that. You are going to use a volumes again. But here understand the replication concept, right? Replication concepts, let's say. Understand the concept of replication, right? There is something called Mongo database repel set or a replication. So you are going to set up the replication, Mongo database replication. In order to set up the database, right, replication, in order to set up the database replication, right, you have to have the database process has to be started with some different arguments. So here there are some commands also to add the members to the replication. You can see the database replication. You can initialize the database replication, something like this also, rs.init. These are like a database commands, right? Here, in order to do this, first you have to start the database, Mongo database with some arguments. So here, they're trying to explain all these things. What is replication? Why do we need replication? As I already said, you have something called primary, we have something called secondary. Your clients are database clients or application will contact primary for read, secondary for read, and this primary will replicate the data to the secondaries like that, right? Here there is a health checks, heartbeats also between them. If primary goes down, secondary will become a primary. This is database concepts, right? Here, when you are trying to initiate this database also, when you are starting the database process also, you need to start the database process with some commands. You have to start the database process with some commands. That is what they are also explaining here. So you have to initiate the database process with some commands. They're explaining all these things. By default, it will execute one command. Suppose, just to give an example, suppose you have started Tomcat, you have used a Catalina data, such a start like that. But similarly, here Mongo database process will be started using one command called MongoDB command. But along with that command, you have to pass some arguments to initiate the replication in order to start the database process in a replication mode. Then you can set up the replication. Otherwise, you can't do that replication, right? So here, let me say start Mongo MongoDB MongoDB in replication mode. In order to start that MongoDB in a replication mode, you have to execute this MongoDB command with some other arguments also. We have to do that. So that is what they are also explaining here. That is what they are also explaining here. We have to execute some commands. Okay. So here, if you see, this is the link. Deploy repel set MongoDB repel set, that is not Kubernetes replica set like that. So you have to start the database also with some commands. So considerations when you are deploying a Mongo database repel set or a Mongo database replication. So you have to start the database process with some additional commands, like these type of commands, arguments, I can say, some other arguments, something like this. Repel set name, MongoDB hyphen repel set. This is like a name of the repel set, that replication name, database replication name. And here hyphen bind IP, like that you can give local or 0.0.0. 0.0.0 means basically that applications talking to this database servers or databases can be from any other machine also. Like if I say 0.0, you are allowing the clients like a database clients to talk to this database from specific IP, or you can say 0.0 also, like this. So after starting the database process with this arguments, then you can initiate the database replication by adding the members like this. This is database command. Here you can give IP address or a host names like that, whether you are doing a replication in the servers or a containers in Kubernetes, that doesn't matter. So this is the documentation, right? So you can, this is most of the time DBS will do, but since I am explaining this in Kubernetes, I am trying to explain this. So let me create a stateful set for now. Stateful set. Now we have already deployed a database, Mongo database, but not as a stateful set. In my cluster, I already have a database, but we have only one pod. You have only one pod. Let's imagine something goes wrong with that database replica, that pod. Before it is going to be recreated or replicated, if any applications is trying to access the data from that DB, it will not work. And again, if so much database request goes to the database process, again performance bottlenecks, slow responses, timeouts, these type of things will come. Let me show that. Let me connect to my cluster. Let me connect to my cluster. I have these many nodes in my cluster as of now. We have created some namespaces. We have created some namespaces. kubectl get ns. So we have some namespaces, and in that namespaces we have some pods. Now, just now I have started my servers. I had shut down my servers. So just now I have started my servers. Again, pods also started automatically, but we have a readiness probe, liveness probes we have defined on this. So it is waiting for the probes to be get finished to consider that as ready. Now you can see I have a database pod. I have this application pods also running. This database pod I have deployed using a replica set array deployment with one replica as of now. One replica as of now. Then you can see we are using persistent volume claim as a volume that is mounted to this, and we have a PVC created, and for that PVC we have a volume associated for that PVC. This volume is created dynamically because of the storage class. We have a storage class configured with this NFS provisioner. There is a volume. Now we have a single pod. Let me access my application. Let me access that application internally talking to the database via that service name. Let's say this is my application service, student management service. We have a node port service. Let me use that node IP and node port. Now this is my application, right? Application is internally talking to the database, and you can see there is a data also. Let's say I'm creating few more records. Let's imagine this application is talking to the database. The database is storing the data in the given value like that. Imagine something went wrong with this node where that database pod is running. Imagine something went wrong with this node where the database pod is running. Or imagine something went wrong with the storage where the database is using that storage to store the data. Right? Again, that time you may have some problems. I am deleting this pod intentionally. Before it is going to be recreated or replicated, if your applications are trying to access, you don't see any data. Here internally, you may see some kind of errors or exceptions also. You can see some errors or exceptions also like that, right? It is trying to fetch the data of the users, right? You can see it is not able to fetch the data also. Sometimes the timeouts may come. You can see request is going to this API. API is taking some time. It is still not responded. But by the time the database is started again, and maybe it will give the data. But if it is not ready, then it will give timeout or errors, 500 errors like that. Right? So that is what the problem. That is what the problem here. Right? Here performance also will be there. You can replicate the database. Now let me do that by using a stateful set. I will create a multiple replicas, and I will set up the replication also. So kind stateful set. So here I can give any name, MongoDB or whatever, and here namespace. Make sure I will create this also in the same namespace. And here I will try to have a 3 replicas or whatever according to your requirement. Let me go with the 3 replicas. And here I will say MongoDB like that. The labels, you can give anything. Labels and selectors. Container name I am giving like this. And the image is this from Docker Hub. And port number 27017. This is like a name which you wanted to give, you can give, otherwise leave it, port name. And here I will say like a volume claim template, I will say Mongo volume like that. And this is what I am going to use. And here I am saying I need maybe 1 GB, 2 GB like that. Using this volume claim template, PVCs will be created. How many PVCs will be created? based on the number of replicas. Suppose here I have given 3 replicas, 3 PVCs, and each PVC will be associated with the one pod like that. Here the mount path is also like this, right? If required, you can define liveness probes, readiness probes, that same, whatever, if required. You can do all these things also if required. This liveness probes, readiness probes also you can define like TCP socket. This we have already discussed all in a detailed way. What is this liveness probe? What is this readiness probe? And also you can define resource request and limits also. Readiness probe, if required, you can create like this readiness probe. And again, resource request and limits. Resource request, resources like how much you need, minimum 256 megabyte, 500 millicore, or you can say 512. It is based on your requirement. For now, I am just requesting less because it is a learning environment. I have a very less servers with less capacity. So I am just requesting, limiting less, but in real time, it will be more. Okay. Like this, all these concepts we have already discussed. Okay. Now you can use according to your requirement. All these things also you can define, right? Liveness probe, readiness probes like this. But understand here service name. So I have to create a service also myself, right? So here I am going to create a service, but what type of service it is expecting? Headless service. I will give, let me give MongoDB. Let me give something like this, MongoDB hyphen SVC like that. So here explicitly I have to tell cluster IP none. Cluster IP none. This is headless service. And my pod labels are used as a service selectors here. Same. And port also, let me say 27017. Target port also, let me say 27017. Like this. But understand here, this service name has to be given here. Like this. And I am creating 3 replicas, 3 pods. But make sure, as I already said, this MongoDB image, this is also basically container. We are creating a pods using stateful set. Pod has a container. The whatever CMD we have given, that will be executed by default. But the default CMD here is maybe you can see official website of maybe hub.docker.com. This from here only we are using image. Let's say Mongo image. So we have some default CMD. You have some default CMD. If you see the Docker files also, they have given links to the Docker files. You can see, maybe if you open some of the Docker file, you can see they are using Ubuntu as a base and they are building. We have some CMD, just MongoDB, right? This is the entry point, and this will be passed as an argument to that entry point, but this is only MongoDB. But in case of database replication, we have to start the database with some, not only just MongoDB, these type of options we have to give, as I already said, right? You have to start your database process with the REPL set name and some other arguments you have to give. But suppose if you are using Docker at runtime, are we able to override the default CMD while creating a container itself? Can I change the default CMD at runtime? If you guys remember Docker concepts. Yes. So what you are doing, like this is what you have done. Docker run or a create you are using, and your image, and you are passing the arguments here. That commands are arguments, whatever. So whatever we are passing, these arguments are commands here, that will replace this in the Docker file. We have some CMD like this. This CMD will be replaced with what you are passing at runtime. But in Kubernetes, you are not directly creating using this Docker commands or any other containerized commands. But here also, is it possible to pass that arguments or commands? Can we override in this specification? Can I pass the details also if required? Yes. So for that one, we have options. Right? We have options to pass that, right? So you can use you can use that specification. You can use that in this specification also. You can pass that CMD. I mean to say you can override by using some option, right? So here you can use something called command or args like that also you have. Command or args like that also you have, right? You can pass arguments or a commands, right? You can override the command itself and you can do that. Let's say here there is one option called C command. Here you can do something like this command. So here anywhere command like this. But here command is this, arguments are like this also you can say. Otherwise if you leave this command, but arguments only you can pass also using args like that. There is something called args. Args means again it is not going to replace this CMD. I mean say it is not going to override this CMD. So whatever we are passing as an args, right, that will be passed to this CMD. But if you are directly saying CMD also, then it will replace. It will replace. Let's say I will go with this command like this, and here like this again other options. These options are nothing to do with stateful set. This is to do with the MongoDB. I have to set up MongoDB in replication mode. So I will say all these arguments I wanted to pass. Let's say you can say hyphen bind underscore IP like that. Within double quotes also you can give all these are command, or without double quotes also you can give. It's up to you like this. Command you are overriding, right? Then I wanted to give 0.0.0.0 bind IP, then repel set name. Like here I can say anything. I can give any name. Mongo, that is like a repel set, Mongo database replication name or a repel set name. So I can give something like this also. Something like this. But if you are this is what we are doing actually. MongoD at runtime we are passing something like this. MongoD hyphen bind IP 0.0.0, then hyphen this repel set name, main rip set, like that. Basically this is what we are overriding, right? Now because of this right, in this container, when the Kubernetes with the help of container runtime it will create a container. So instead of only MongoD, this will be replaced with that CMD. So we are going to start that database in a replication mode, but we have to add the replicas again. I mean to say primary, secondary, we have to do that. But while starting I am doing like this. This is nothing to do with stateful set, Mongo database related. Clear? This manifest what I have created, everyone clear before I deploy this? Now let me take this manifest and let me deploy. Before deploying, let me clean up everything for better understanding. Let me delete whatever I have here. This is dangerous command, don't execute. But since it's a learning environment, like you can playground, right? So you can do whatever you would like to do. But for now, I will go with the stateful set. Let me create VA MongoDB stateful set. So let me have this manifest. I am in the single manifest. I am having a service as well as I am having a service, headless service, and as well as stateful set. And you see, we just have a PVC. This is not for this one. This is created for a different application. But now we don't have a PVC. So this stateful set, it will create a PVCs. And we have a storage class already configured. That storage class will create the values for that claims, right? Then there is a service also. Let's deploy this. Namespace name, I have mentioned test-ns. Okay, service also same namespace. Let me mention that. Let's deploy this. Namespace, there is a spelling mistake. Let's see this. Now, one after the other pod will be created, not all. Even I have said 3 replicas, right? Now it is creating only first pod. The pod name is like a stateful set name, hyphen increment like 0. This is running, but it is not still ready because we have defined the readiness probe, right? So unless until the readiness probe is successful, then only it will become ready. Once that is ready, then only second one is created. Once that is ready, then only third one will be created. And again, each pod will have its own PVCs now. And for that PVCs, we have not created a PVs manually as an admin. The storage class, you can see MongoVal -MongoD01, MongoVal -MongoD1, MongoVal -MongoD2 like that. The PVC is also created using that volume claim template. Now each PVC has its own PV configured via that storage class. That storage class can be any storage class with any provisioner. Now your pods are there, but we just have a 3 pods. We just have a 3 database pods, but which doesn't mean one is primary, one is secondary like that. One is primary, one is secondary like that. You have to set up that. You see there is a service also, headless service, cluster IP, none. So you don't see any IP, but this service will have its endpoints. It will give all the pods as an endpoints, but it won't do any load balancing. Suppose anyone is using this service, it will give all these endpoints. So whoever is trying to communicate with the pods via this service, they can only choose which pod it has to connect also, like that. Again, if you see, we just have a 3 pods, but nothing is primary, nothing is secondary. So I have to do this setup. I have to do this setup. Maybe if you see, this is database concept. Once this is done, I can go and initiate, and I can add the database IPs and respective ports like that. In one of the replica, I can do this. This will become primary. Out of these 3, one will become primary. Then primary knows where the secondaries are running, like that. This is database concept, right? Now let me connect to one of the database pod. kubectl exec -it. Let me go inside one of the database stateful set. This is one-time activity. You can do that. This replication setup. Now you can see host name -f. So this is the host name of the pod. That pod. This is the host name of that pod. Let's say this is the host name, MongoD -0, that is pod name, and also service, that headless service name, .namespace name, .svc, .cluster, .local. This is like a fully qualified domain name of that pod host name. Even though this pod is deleted and recreated, again you will get the same host name, that is stable unique network identity. This pod may have a host name like this. This pod may have a host name like this. This pod may have a host name like this, right? So like a stable host name, and each pod has its own values via claims also. Now let me connect to the Mongo shell. Let me connect to the Mongo shell. I will set up the replication. Mongo sh command I am executing to connect to the Mongo shell. And here we are not, we have not protected the database with username and password. When we created this stateful set pod also, we have not given that environment variables, because the configurations is little different when we are setting up the database in a replication mode. So first let me initialize the replication. I connected to the Mongo shell. Now I will execute some command like this. but don't copy paste as is and understand the concepts. So here my replication name, that database replication name is like main rip set I have given. That is what I have given. And here I will take this like this, and the port is 27017. Same. This is one more member. We are just adding we are initializing the database replication. We are adding the members to that replication who should participate in the database replication. So these are like a members of the database replication. And out of these three, one will become a primary. As of now, we have not done that. If I execute rs.status, this is database command. rs.status, Mongo database command. If you see, I connected to the Mongo shell and executed, it is saying no ripple set configuration is been done. As of now, nothing is done. Let me do this. Now I have, let me press enter. Now the replication is initialized. The database replication is initialized, and while initializing the replication, we have given the members details. Now let's say, after this, let's say execute that rs.status to see the replication. Now you can see this configurations, right? So we have total 3 members. This is the name of the replication. We have total 3 members. This is one. This is one member, like a host name or IP. This is another member. You can see this is secondary. This is also secondary. Now this became primary. Out of these 3, one became a primary, and the rest of the 2 became secondary. Now primary knows where the secondaries are running. Now if any application is talking to this databases, right? Primary will be used for read, and primary will be used for write operations. Secondary will be used for read. But primary knows where the secondaries are running. It is going to sync the data. Sync. So you can see this is database concepts, syncing from which source it has to sync. So from which sync, this secondary will sync the data from primary. Like that, you can see some kind of a settings here. This is database concepts, right? But anyhow, I have to protect my database with some kind of a username and password. I have to protect my database with some kind of a username and password. Here, I will execute some database command. Again, I will execute some database command to set the admin username and the password. So I will share this in a running notes also. Don't worry, right? So I will execute one command to set up the protect the database with some username and password. Let's say this is what I'm going to do. Like this is the username and password of root admin username password. Like that, I'm executing one database command only in the database shell. Now the database replication is done. You can see here itself, this is primary like that. Let me exit. Now we have a replication. Let me exit from container shell also. Now we have a replication. Now let's deploy the application talking to the DB, right? So let me deploy my application, that student management application. In this student management application, I can use that service name to talk to the DB. That service name is little different. I have given the headless service name itself. I can give the MongoDB -svc like that. And username and passwords you can take from config maps or secrets for this application. For now, I have a different password. Let me directly give that, because the password is not same as what I have already created in the config map. Password is devdb123 I have given, and username is devdb. Maybe you can have this in the config maps and secrets and refer also. We discussed about that config map secrets also. For now, let it be directly here, devdb123. This is what my username, this is what my password I have set to the database, right? Now this is my application talking to the DB. Since we just deployed the database, you don't see any data, because just now we set up the database in a different way, right? So you don't see initially any data. Now let's access your application ports via services. Again, we have a liveness probes, readiness probes, all these things. Once these pods become ready, we will try to access. Just give me just 10-15 seconds. right? We'll continue. Okay, let's see if the pods are ready. Application pods are ready, and via this application service, this node IP node port will try to access the application. Initially, this is a new database, right? Completely different database. You don't see any data. Application is talking to this GUI. This is a typical three-tier application that I have deployed in a Kubernetes, right? So if you see, this GUI is internally talking to the APIs. This API is giving 200 response with the empty response because we don't have a data as of now. Let me create a few records. Let's say this application is internally talking to the DB. This data is being stored in the DB, but database is replicated now. Primary, secondary, like that. This data also multiple copies of the data, multiple database process also there now. Now application will talk to the primary for write, secondary for read, like that. Now you see this data will be replicated across all those replicas. Now imagine something goes wrong with this database. Let's say something goes wrong with this database pod, or maybe something goes wrong with this database node. That doesn't matter, right? Let me intentionally I'm deleting one of the database pod, but these pods are managed by stateful set. Again pod will be created. Again, that pod, when it is going to recreate, it will have a same network identity whatever it has last time, and the same storage also it will use again. But we have a database replication done. So if because of the database replication, the primary is down, the out of secondaries one become primary. And again, once this is back, again this may join as a secondary, like that, because IP or a host name is same. I mean, it's not IP, host name is same. It is going to have a same network identity. Let me intentionally I am doing this. I am deleting this. Now you see, you access your application, you don't see any data loss also. I mean, say you see data is also coming, right? Even the one of the database pod is gone, because the replicas are there secondary. In the primary, the data is replicated to the secondary. Now write operations also will work, because one of the secondary might have become primary by this time. Right? So you can see again, write operations also will work, but it is taking some time, because let's wait. Write operations should work. Yeah, write operations also working here. Without any problems. Read operations also working, write operations also working. At the same time, this again, whatever went down, it came back. But maybe this is not primary now. Maybe if I go inside that, let's go inside that. Now you connect to the Mongo shell. Again, it will have a same host name, whatever it was there last time. same host name, stable network identity. And let me go to that Mongo shell. Let me execute. Now you can see here itself, this is like a secondary. Now this is not primary. Last time it was primary. This is database concept. Now you see rs.status. You can see now this became primary. This became primary. This joined back as a secondary like that. So this is how you can use stateful set for managing the stateful applications, and stateful set is going to be providing stable network identity, stable storage, and again ordered deployments and updates also it will provide. Any of your applications, is if any of your application requires stable network identity or a stable storage or ordered deployments, then you can go and use a stateful set. So not only just Mongo database, any other stateful set, any other applications, stateful applications also you can set up as a stateful set. But at the same time, today I am explaining two different concepts: database replication also. Database replication also. If you wanted to use stateful set with single replica also, you can do that. Without database replication, you can directly do the stateful set with single replica without executing that Mongo, that command, starting the database with the replication mode, and without having multiple replicas, without joining a primary, secondary also. If required, without replication also, you can set up a database with one replica also if required. The way we have done it with the deployment or replica set, just create one pod, don't do any replication also. But this database replication concept also I have tried to explain so that you can understand how things works in the databases also real time. So everyone clear? Whatever has been explained today, very, very important session, right? You might be using this already if you are working, or maybe you can use all these concepts when you are going to work in any new applications or projects. So once your practice is done, if required, you can delete everything, replica set, other stateful set, application pods, stateful set pods also. But the values created by the stateful set will not be deleted because of the data safety. If you wanted to explicitly delete, you can delete again PVCs and PVs again. Okay. So try to practice whatever has been explained today. From here, we will continue in the next session, that is tomorrow. In tomorrow, we'll try to understand different concepts. We have something called network policies, resource quota. Very, very important concepts. We have again network policies, resource quotas, like that. I'll try to cover that concepts in the tomorrow session, guys. As I already said, guys, this November 29th, we have a new DevOps with AWS batch starting up. If any of your friends, colleagues looking for DevOps training, right, let them know. November 29th, we have a demo, and regular classes will start from December 1st. Let them know. Ask them to reach out to me on the given numbers. Otherwise, they can visit our YouTube channel where they will get the updates also, right? Or maybe they can reach out to me using this. So here I have given the details about this upcoming batch, right? Let them know if any of your friends, your colleagues looking for DevOps training, right? From November 29th, we will start. From here, I'll continue tomorrow, guys. If you have any specific questions or specific queries, let me know. Otherwise, I'll stop the session here and I'll continue tomorrow. I will share the running notes also for this. Try to practice this stateful set. Not only MongoDB, as I already said, you can use for anything. MySQL with the replication, without replication, again, Prometheus, Jenkins, Kafka, any type of softwares you can use. You can deploy in Kubernetes according to your requirements by using these Kubernetes resources. Thank you, guys. That's it for today. Have a great day. We'll continue tomorrow with other concepts. See you tomorrow.